I would now like to do another example where you're solving a trig equation but you don't have a single angle. On this one, I'm actually solving where I have a triple angle. We see that on the inside of my trig function, I have a triple angle. Okay, what this means is there's going to be triple the amount of answers that you would normally get. In other words, if you solve on 0 to 2 pi and you normally get 2 answers over that interval, you're going to have a total of 6 answers for this particular question. As before, if you don't have a single angle on the inside of your function, what I'd first like you to do, make sure you understand that this particular interval is for theta by itself, okay, and say that if for theta by itself, your values lie in between 0 and 2 pi, then for triple that, we would have 3 times 0, we'd have 3 times theta, and then we'd have 3 times 2 pi. And so I would have for my triple angles, my angles lying in between 0 and 6 pi. Alright, let me take my answer, or let me take my original question and work it down below. So I have square root of 3 times the tangent of 3 theta plus 1 equals 0. First, I'm going to solve that for tangent of 3 theta. Subtract over 1. You have the square root of 3 times tangent of 3 theta equals negative 1. Divide both sides by the square root of 3. And so we have the tangent of 3 theta is equal negative 1 over the square root of 3. Now, you absolutely cannot divide both sides by 3 to get rid of the 3 with the theta. The 3 that's with the theta is stuck inside of the trig function. You cannot do any algebra to get rid of that 3. Okay, from here, I actually need to take this and I need to rewrite it. I know that tangent's the value y over x. There's two different ways I can consider this. I can consider it as it is, or because I don't have restrictions on the signs of y and x, I could put the positive with the 1 and the negative with the square root of 3. Now, which quadrants does this occur in? The first thing you want to consider is you want to consider between 0 and 2 pi, which quadrants would these two situations occur in? Okay, in which quadrant is y negative and x positive at the same time? Okay, well, y is negative in quadrants 3 and 4. The only time that y is negative and x is positive is in quadrant 4. Okay, in which quadrants are y positive and x negative? Well, y is positive in quadrants 1 and 2. The only time that y is positive and x is negative is in quadrant 2. Alright, so we want to draw pictures in these two quadrants. Alright, we've got one picture in quadrant 4, and we've got one picture in quadrant 2. Let's label our sides. In quadrant 4, we have a negative y value, which is negative 1, and we have a positive x value, which is the square root of 3. Okay, this forces this to have a reference angle of 30 degrees, and it forces the hypotenuse to be 2. Same thing in quadrant 2. In quadrant 2, the y value is positive 1, the x value is negative square root of 3. The r value is forced to be 2, the reference angle would be 30 degrees. Alright, so let's first determine in radians what these two angle measures would end up being. Now, when I'm saying these angle measures, I'm saying that there's going to be one angle measure from here to here, that's 3 theta, and I'm going to say sub 1, and then there's going to be an angle measure from here around to here, and that's going to be 3 theta sub 2. Make sure that you're indicating the angle that's in your trig function when you draw this picture. It's not theta, it's 3 theta. Okay, in radians, 3 theta sub 1. Okay, it's a 30-degree reference angle in quadrant 2. A 30-degree reference angle means it's something pi over 6. This angle in quadrant 2 would be 5 pi over 6. Okay. 3 theta sub 2 is in quadrant 4. That particular angle in quadrant 4 is also a multiple of pi over 6. You can think about 12 pi over 6 as being all the way around, and so this would actually be 11 pi over 6. Okay, now, here's the deal. These two angles are between 0 and 2 pi. From each of these angles, you create two other angles by rotating them around an additional 2 pi units. So in other words, this one is going to have another created from it. You're going to have, let's say, 3 theta sub 3 being 5 pi over 6 plus 2 pi. And you're going to have one other, let's call it 3 theta sub 4, equaling that value that you just got, plus an additional 2 pi. And instead of saying 2 pi plus 2 pi, I usually just say plus 4 pi. Okay, so here's what I think of, and I'm not done with this, but I think of this as that's one rotation, this is 2 rotations, and this is 3 rotations. And I know that's proper because this is 3 theta instead of theta by itself. Okay, the same thing for this other angle. Okay, let's say that this one, we're going to have 3 theta, let's see here, we're on angle 5. 3 theta sub 5 is equal to 11 pi over 6 plus 2 pi. And then we're going to have one additional angle, 3 theta sub 6 is going to equal 11 pi over 6 plus 4 pi. So there's going to be our 6 different angles. Now what I'm going to do, I'm going to reorganize this information so that we can see it a little bit easier. We're going to have to do some common denominators before we're done with this particular problem. So let me reorganize. Okay, 3 theta sub 1 was equal 5 pi over 6. 3 theta sub 2 was equal 11 pi over 6. 3 theta sub 3 was 5 pi over 6 plus 2 pi. There, I need to find a common denominator. Put 2 pi over 1, and then multiply the top and the bottom by 6. So this is 5 pi over 6 plus 12 pi over 6, which equals 17 pi over 6. 3 theta sub 4 was 5 pi over 6 plus 4 pi. I need a common denominator there. Put it over 1, multiply the top and the bottom by 6. So this results in 5 pi over 6 plus 24 pi over 6, which is 29 pi over 6. 3 theta sub 5, that referred back to the 11 pi over 6. I needed to add 2 pi. I need a common denominator, multiply once again by 6 over 6, and so we'll have 11 pi over 6 plus 12 pi over 6 equals 23 pi over 6. And then finally, 3 theta sub 6 equals 11 pi over 6 plus 4 pi over 1. Multiply to get a common denominator by 6 over 6. We have 11 pi over 6 plus 24 pi over 6, which gives me 35 pi over 6. Now the final step on this kind of a problem is that every single one of my answers to this particular point is 3 theta sub 1 or 3 theta sub 2. The final thing I need to do is I need to solve each one of these equations by multiplying both sides by 1/3. So in other words, doing that is going to simplify out my 3's, and then it'll give me my proper answer for just theta. Theta sub 1 would equal 5 pi over 18. Okay, multiply each of these by 1/3. Theta sub 2 is going to equal 11 pi over 18, and so forth. Okay, so let me write these down out here kind of to the side. Theta sub 3 equals 17 pi over 18. Theta sub 4, 29 pi over 18. Theta sub 5, 23 pi over 18. And then finally, theta sub 6 equals 35 pi over 6. So the final answers: theta sub 1, 5 pi over 18. Theta sub 2, 11 pi over 18. Theta sub 3, 17 pi over 18. Theta sub 4, 29 pi over 18. Theta sub 5 is 23 pi over 18. And then finally, theta sub 6 equals 35 pi over 18. And I need to correct that. I see I have the wrong denominator right here. Okay, and those are your final answers. You have 6 answers. That's what we said we should have originally, and we have that. This concludes this lesson on solving trig equations.